Welcome, my name's Jeff. This is my experience with Emulsifier E471 and why I believe it should no longer be used. With 100% accuracy, anytime I consume E471, I will have diarrhea shortly after consuming it, and then this kicking nightmare that night. I've never had a kicking nightmare without E471. I have for the last 6 months avoided E471 and have had no nightmares, and my gut is much better. Any time that I did experience either of these events, I went back and found that I had inadvertently consumed E471. The link was 100%. What does all this mean? For me, E471 was causing a gut inflammatory response, and that was leading via the gut-brain axis to a neurological response. While I was having the nightmare, I was kicking at something that was attacking me, but which I did not know what it was. This is concerning for two primary reasons. Firstly, the food authorities say E471 is safe, and secondly, it is accepted that this type of REM sleep disorder is associated with neurological diseases such as Parkinson's disease. So let's find out what we can about E471 and let's evaluate the science. Here are some examples of Australian products that contain E471. There are 33,090 European products that contain E471. Most of these, or 75% of these foods, in the dairy-based ice cream and frozen yogurt category. Some other categories have a lower percentage of E471. Overall in Europe, 7% of all foods contain E471. Cumulative effect of E471. Hypothetically, if you started the day with toast and margarine, then had a sandwich with margarine and a piece of cake for lunch, then had pasta for dinner with a yogurt or ice cream, and finished your day with a biscuit, you would have consumed quite a lot of E471, as almost all of those items contained E471 in them. Interestingly, the European Union exposure levels by age group. And interestingly, maybe the question is early onset Parkinson's disease a result of increased levels of E471 at a younger age? You can see that there's a higher level for toddlers and children in the exposure of E471. That exposure is a conservative estimate. Don't forget natural mono and diglycerides also occur in other products. Not all products disclose the use of E471. For example, Australia allows the labelling of E471 under labels such as breed enhancer. A further concern was the Australian Food Standards Association, who have provided authority for DuPont to use an enzyme called triglycerol lipase. This is effectively a mono diglyceride. Because of the process involved in its manufacture, the Australian standard allows for this without it being labelled on foods. This presents a huge problem for people like me, as I will be unable to identify where E471 or those mono diglycerides have been used. The European Food Safety say E471 is safe. Accordingly, the panel considered it is very likely that hydrolysis of monodiglycerides of fatty acids by lipases in the gastrointestinal tract would occur, resulting in the release of glycerol and fatty acids. The panel re-evaluated glycerol and fatty acid as food additives and concluded that there was no safety concern regarding their use as food additives. To my comment, it is far from clear that metabolism of E471 follows this path. It is not within the scope of this study to consider the safety of glycerol and fatty acids, but the reasoning that because they had previously declared that E422 and E570 are safe and so therefore E471 is safe is not convincing. The World Health Organization describes E471 metabolism in a different way. There are considerable differences in how the metabolism process is described. The WHO describe a process where triglycerides are broken down by the gut into mono and diglycerides, pass through the gut wall, and are then converted back to triglycerides. However, they say that the consumption of additives, mono and diglycerides, may not follow the same metabolic process. Only one conclusion can be drawn, and that is that the current available studies are inconclusive, and how humans digest, absorb, and metabolize E471 is unclear. Rats, there's a problem here. On the table before you, you can see that the area that's highlighted, a rat gut is quite different from a human gut in the areas of the stomach, the small intestine, the caseum, the appendix, the colon, and various other aspects. We can see that these differences are significant, cast significant doubt on the use of rats and mice or murine models as a model for human absorption. It's hard to draw any reliable conclusion on how mice and rats digest fats and lipids, and more specifically glycerides, and then directly relate that to humans. In addition, the mouse gut-brain axis has biological differences to the human gut-brain axis. Is something else missing in the science? Yes, all food authorities focus on potential carcinogenic risks of additives and some obvious toxic or anaphylactic responses, and more recently the potential for genetic damage. Nearly all studies are based on short-term mouse studies, and no consideration is given to long-term disease development. The consideration of neurological diseases being caused by food additives is absent, and yet neurological disease is rapidly increasing across the world. Even shorter-acting diseases like ADHD are not considered. What do we know about glycerols and neurological diseases? I'll just read out the highlighted components here of each of these studies. The first report stated that neural membranes contain several classes of glycophospholipids, which turn over at different rates with respect to their structure and localization in different cells and membranes. The glycophospholipid composition of neural membranes greatly alters their functional efficacy. These processes, along with the accumulation of lipid peroxides and compromised energy metabolism, may be responsible for the neurodegeneration observed in neurological disorders. More specifically, diglycerides and Parkinson's disease. In this report, in Parkinson's disease, asynuclein pathologically impacts the brain, a highly lipid-rich organ. We investigated how alterations in alpha-synuclein, or lipid fatty acid homeostasis, affect each other. Lipidomic profiling of human AS-expressing yeast revealed increases in oleic acid, diglycerides, and triglycerides. In this report, here we provide an overview and discussion of the main findings relating to asynuclein lipid interaction and its involvement in the modulation of lipid metabolism and signaling. In this report, a growing body of literature has emerged in recent years that clearly demonstrates the involvement of glycolipids in the protein oligomerization of neurodegenerative disorders. We've hypothesized that changes in glycolipids composition are a common mechanism underlying the shift from healthy brain aging to neuropathological processes of neurodegenerative diseases. And in this one, these findings offer a conceptually new model to explain how fatty acid and monoglyceride interactions can trigger phospholipid membrane remodeling events relevant to various biophysical and biological systems. A summary of this research is The previous slides demonstrate growing interest in the role of lipids, glycoproteins and glycerols, for which mono and diglycerides are members of, in the development of neurodegenerative diseases like Parkinson's and Alzheimer's. The previous article describes research that has shown a clear connection between the mono and diglycerides and the misforming of proteins that are connected with major neurological diseases. There remains considerable work left to do to fully understand the interaction of mono and diglycerides and the development of neurological disease. However, food authorities have totally ignored or disregarded this research or connections. Food authorities need to include the assessment of additives for their potential to cause neurological disease, and they need to use research that is based on species-specific studies and not rely on murine models. Future research also needs to consider the effect of heating lipids in the production process and the resulting production of byproducts. The baking of bread serves as an example, for at the temperatures of bread baking, lipids will be altered. There's some additional notes that are provided by the European Union Commission about the E471 containing other impurities, including heavy metals, toxic elements like arsenic, cadmium, lead and mercury, and also the possible production of 3-MCPD. Okay, both of these are involved in, all of these are involved in potential neurological disorder and other diseases. We wrote a letter to the Australian New Zealand Food and Safety, and this is their response. The safety of E471 has been extensively reviewed by national agencies and international expert bodies that deal with food safety, including the Joint FAO and WHO Expert Committee on Food Additives, the European Food Safety Authority, and the United States Food and Drug Administration. These reviews have concluded that E471 is safe at current use levels. FSANZ scientists regularly contribute to the work of these authorities. It is not aware of any reports in the scientific literature of adverse reactions to E471 in humans. As a result of my personal response to E471, I undertook a study that showed that what FSANZ told me was deficient. The science is dubious as a result of dependence on murine models. I also found that the studies don't look at neurological disease. As consumers, we should not accept this, and we should avoid products that contain E471. Our political leaders and authorities should be doing more to protect the community from E471.